A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine you are an engineering manager at a massive e-commerce company. You have 50 developers, all trying to push code to the exact same front-end repository. Every time the checkout team wants to change a button color, they have to wait for the search team to fix a broken unit test in a feature they do not even use. It is a nightmare of merge conflicts, 4-hour build pipelines, and endless Slack coordination just to ship a typo fix.
That is the classic front-end monolith problem, and it is exactly why today's prompt from Daniel about micro front-ends is so timely. I am Herman Poppleberry, and honestly, Corn, this topic is the ultimate be careful what you wish for of software architecture.
It sounds like the front-end world finally looked at the back-end guys having all the fun with microservices and said, hold my beer, we want some of that operational complexity too. By the way, before we dive into the architectural weeds, fun fact for everyone, today's episode is powered by Google Gemini 3 Flash. It is helping us sort through the chaos of distributed UI.
It is a perfect fit because micro front ends are essentially the architectural equivalent of breaking a giant puzzle into a digital Lego set. Instead of one massive React or Angular application that contains every single page and component, you break the site into independent fragments. One team owns the header, another owns the product carousel, and a third owns the checkout flow. They each have their own repo, their own deployment pipeline, and they can ship code on Tuesday at 10 in the morning without asking anyone else for permission.
Okay, but as a sloth who values efficiency, that sounds like a lot of extra work just to avoid talking to your coworkers. Is this really just about team autonomy, or is there a technical performance play here too? Because I have seen some of these implementations, and sometimes it feels like we are just reinventing the iframe and calling it a revolution.
We are definitely not just reinventing the E-frame, though we will get to why people think that later. The primary driver is absolutely organizational scaling. When you hit a certain head count, the human cost of coordination starts to outweigh the technical cost of a complex architecture. If you have 5 developers, micro front ends are a straight-up disaster. If you have 500, they are a necessity. Think about a company like IKEA or Spotify. At IKEA, the team managing the kitchen planner tool is completely different from the team managing the loyalty program. Forcing them to share a build process is like forcing 2 different construction crews to share a single hammer.
I like the hammer analogy, even if you're not supposed to use analogies. But let us get into the how. If I am a browser, how do I actually see these different pieces as one cohesive website? Is the server stitching them together, or is my browser doing the heavy lifting at runtime?
That is the core technical hurdle, and there are 3 main ways people are doing this in 2026. The first, and currently the most dominant, is client-side composition using something called module federation. This was introduced with Webpack 5 back in late 2020, and it basically changed the game. It allows a host application, often called the shell, to dynamically load code from a remote application while the user is browsing. It is like the browser is downloading a recipe and then fetching ingredients from 5 different kitchens as it needs them.
And the browser is smart enough to not download the same bag of flour 5 times. Because that is my big worry here. If every micro frontend brings its own version of React, my browser is going to be wheezing under the weight of 5 different frameworks just to show me a shopping cart.
That is the famous micro front-end tax. If you are not careful, you end up with payload bloat that kills your core web vitals. Module federation tries to solve this by allowing shared dependencies. You can tell the system, hey, we all use React 18.2, so if the shell already loaded it, do not fetch it again for the fragments. But that requires a lot of governance. You need a central authority or a very strict contract between teams to ensure everyone stays on the same versions.
Which sounds like more coordination, the thing we were trying to avoid in the first place. You trade talking about code for talking about dependency versions. It feels like moving the furniture around in a room that is still too small.
It is a different kind of coordination. It is asynchronous. You set a standard once a quarter instead of every single morning at stand-up. But you are right, the complexity does not disappear, it just moves to the infrastructure. The second big pattern is server-side composition. Tools like Tailor.js or Podium do the stitching on the server. The server fetches the HTML fragments from different services, assembles them into a full page, and sends that to the user. This is much better for SEO and initial load speed because the browser gets a finished product rather than a blank page that then has to go fetch 5 more things.
That sounds like how the web worked in 1998 with server-side includes. Are we just going full circle back to the early days of the internet?
In a way, yes, but with modern state management and interactivity. The third way is using web components. This uses native browser APIs like custom elements and Shadow DOM to wrap micro apps. This provides the strongest isolation because CSS from the search fragment cannot accidentally leak out and turn the checkout buttons neon pink. It is the most robust way to ensure that teams do not break each other's UI, but it can be a bit of a pain to get complex data flowing between those elements compared to a pure JavaScript approach.
I want to go back to the IKEA example you mentioned. How does that actually look in practice? Does the user click a link and the whole page stays the same except for the middle section which swaps out for a completely different app? Or is it more granular, where the search bar is its own little micro app, living inside a header owned by someone else?
It depends on the implementation, but the most successful ones are usually page level or large, fragment level. At IKEA, they used micro front ends to allow different business units to manage their own sections of the e-commerce journey. One of the biggest wins they reported was the ability to do incremental upgrades. Imagine you have a massive site written in an old version of Angular. In a monolith, upgrading to React would be a 2-year project where you have to freeze all new features. With micro front ends, you can leave the old stuff alone and just build the new gift card section in React. They live side by side on the same page.
That is actually a huge selling point. The strangler fig pattern for front ends. You slowly replace the old monolith piece by piece until the old code is just a tiny shriveled vestige of its former self. I can see why a CTO would love that. It lowers the risk of a big bang migration, which almost always fails.
And speaking of success stories, Spotify is the poster child for this. They actually moved away from their famous iframes in the desktop app approach toward a more integrated micro front-end architecture for their web player. They reported that after settling on their current model in 2022, they saw deployment times drop from hours of waiting for a massive CI pipeline to just minutes. Each squad can deploy their specific slice of the player whenever they want.
Okay, Herman, you are selling the dream, but I know you. I know there is a but coming. What is the catch? Because if this were all sunshine and fast deployments, everyone would be doing it. What is the actual cost of this tax you mentioned earlier?
The tax is heavy, Corn. It is a luxury tax. First, there is the operational complexity. Instead of one CI/CD pipeline, you now have 20. You need a way to track which version of which fragment is currently live. You need service discovery for your front end, usually managed through a manifest file that tells the shell where to find the latest version of the search module. If that manifest file gets corrupted or a team deploys a breaking change to their shared API, the whole site can just go dark.
A runtime explosion. That sounds terrifying. In a monolith, if I write bad code, the build fails and it never reaches the user. In a micro front-end world, I can ship my search fragment. It passes its own test perfectly, but when it hits the production shell, it discovers that the shell updated a global library, and now my fragment is throwing a 404 error. How do you even test for that?
That is the million-dollar question. You end up needing incredibly robust contract testing and end-to-end suites that run against a staging shell. But even then, you lose some of the safety of a compiler. You are moving from compile time safety to runtime hope, And then there is the UX inconsistency. If the profile team decides they like slightly rounder buttons and a different shade of blue, and they do not check the central design system, your website starts to look like a ransom note made of mismatched magazine clippings.
A ransom note website. I think I visited that one. It is usually my bank's website. But seriously, this seems like it requires a very mature design system. You cannot just have a bunch of teams YOLOing their CSS. You need a shared component library that everyone consumes, which, again, requires a team to maintain it.
Precisely. You almost always need a platform team whose entire job is to maintain the shell, the shared component library, and the deployment infrastructure. So, you have freed up your feature teams to move faster, but you had to hire 5 new people just to manage the glue that holds them together. This is why many experts, like Steve Kinney, argue that for most companies, a modular monolith and a monorepo is actually a better middle ground.
Explain that to me. Because we have talked about monorepos before, briefly in passing. But how does a monorepo give you the benefits of micro frontends without the runtime hope part?
In a monorepo using tools like NX or TurboRepo, you can have different folders for different features. You can enforce boundaries where the checkout folder cannot import code from the search folder. You get the organization and the clear ownership, but because it is all in one repo, it all gets compiled together. You catch those breaking changes at build time. If I change a shared function that breaks your feature, the build fails on my machine before I even commit it.
So it is like having a bunch of roommates who each have their own room and their own chores, but you all still live in the same house and use the same kitchen. Micro frontends are more like everyone living in their own separate apartment and trying to coordinate a dinner party via text message.
That is a surprisingly accurate way to put it. In the apartment scenario, if the guy bringing the stove doesn't show up, nobody eats. In the house scenario, you at least know the stove is there before you start cooking. The downside of the monorepo is that as the team grows to hundreds of people, the build time for that one big house becomes an hour long and everyone is constantly tripping over each other in the hallway. That is when you finally move out and get the separate apartments.
So let us talk about the framework soup trap. Daniel mentioned this in his notes. The idea that you could use React for one part and Vue for another. Is anyone actually doing that in the real world? Or is that just a technical curiosity that people use to show off at conferences?
It is almost always a bad idea. I have seen it happen during mergers and acquisitions. Company A uses React. They buy Company B, which uses Vue, and they want to merge their dashboards quickly. Micro frontends allow them to do that without a total rewrite. But the performance penalty is massive. You are forcing the user to download 2 different virtual DOM engines, 2 different reactivity systems. It is like trying to drive a car that has 1 electric motor and 1 diesel engine working at the same time. It is heavy, inefficient, and prone to breaking.
It sounds like a total disaster for mobile users on a spotty data connection. If I am on a train in a tunnel, I do not want to download 30 megabytes of JavaScript frameworks just to check my order status.
And that is why the 2026 outlook on this is much more pragmatic than it was a few years ago. In 2020 and 2021, everyone was hyped about micro frontends as the next big thing for every project. Now, the industry has realized it is a specialized tool for enterprise scale problems. If you have fewer than, say, 3 distinct teams working on the same front end, the overhead of micro frontends will almost certainly slow you down more than a monolith would.
What about the state management side of things? If I am logged in on the header fragment, how does the checkout fragment know who I am? Do they share a giant Redux store in the sky? Or do they have to pass messages to each other like kids whispering in class?
Sharing a global state like Redux across micro front ends is generally considered an anti-pattern because it reintroduces the very coupling you were trying to escape. If I change the structure of the user object in the global store, I might break 5 different micro apps I didn't even know were listening. The better way is to use a bus system or the browser's native custom events. The shell handles the core authentication and then broadcasts an identity-changed event. Each fragment listens for that event and updates its own local state. It is more work to set up, but it keeps the teams independent.
It feels like every time we solve a problem with this architecture, we create 2 new ones. We solve the deployment bottleneck, but create a state synchronization problem. We solve build times, but create payload bloat. Is there any scenario where a small team should use this? Or is it strictly a you must be this tall to ride situation?
There is one niche scenario for small teams when you are building a platform that is designed to be extended by third parties. Think of something like the Shopify admin dashboard or a Chrome extension style architecture. If you want other people to be able to plug their own UI into your app without you having to review every line of their code or include it in your build, micro frontends, specifically via something like Module Federation, are a fantastic solution. But for a standard SaaS app with 10 devs, no way, stick to a monolith.
I think people also underestimate the emotional toll of this architecture. Developers love feeling like they have their own little kingdom where they control everything. But when your kingdom is just a search bar and you have no idea how the rest of the site works, you can start to feel a bit disconnected from the actual product.
That is a great point. The silo effect is very real. You lose that holistic understanding of the user experience. You might optimize the heck out of your one little fragment, but if the transition between your fragment and the next one is janky because of a loading spinner, the user doesn't care whose fault it is. To them, the whole site just feels broken.
So, if I'm listening to this and I'm starting to feel like my team's monolith is getting too big, what is the first step? Do I start ripping out the header into a separate repo tomorrow?
Definitely not. The first step is what I call logical namespacing. Before you move code to a different repo, move it to a different folder. Tighten up your internal APIs. Use tools like ESLint to prevent unauthorized imports between features. If you cannot maintain clean boundaries in a single repo, moving to micro frontends will only make the mess more expensive and harder to debug. It is like moving to a bigger house because your current one is messy. If you don't learn how to clean, the new house will be a disaster in 6 months too.
That is cold, Heaven. True, but cold. It is the Conway's Law thing again, right? Your software architecture will eventually mirror your organizational structure. If your organization is a chaotic mess of overlapping responsibilities and unclear communication, your micro frontends will be a chaotic mess of overlapping dependencies and runtime errors.
100%. Micro frontends are an organizational tool disguised as a technical one. They allow you to scale your headcount, but they require a very high level of engineering maturity to pull off. You need automated visual regression testing. You need sophisticated observability to see which fragment is causing errors in production, and you need a culture of contract-first development.
Let us talk about that observability part for a second. In a monolith, I have one set of logs. In a micro front-end world, a user has an error. How do I even know which team to page at 3 in the morning?
You need distributed tracing that extends into the front end. You need to tag every log and every network request with the name and version of the micro front end that initiated it. When an error bubbles up to the shell, the global error handler needs to be smart enough to look at the stack trace and say, oh, this came from the recommendations module version 1.4.2. Without that, you're just playing a very expensive game of not my department.
I can imagine the Slack channel now. The checkout page is blank. Not our fault. Our tests are green. Well, the header is fine, so it's not us. Meanwhile, the company is losing $10,000 a minute.
And that is why the shell team is so important. They are the SREs of the front end. They need to have circuit breakers in place. If the recommendations fragment is taking 5 seconds to load, the shell should just decide to not show it at all and let the rest of the page render. A partial failure is always better than a total blackout.
That is a really interesting concept. Graceful degradation at the architectural level. In a monolith, if the recommendation engine throws a fatal error during rendering, the whole page often crashes. In a well-built micro front-end system, the user just doesn't see the "you might also like" section, but they can still buy their shoes.
That is one of the genuine understated benefits. Resilience. But again, you have to code for that. You have to wrap every fragment in an error boundary and a timeout. It doesn't happen by accident.
So, looking forward into the rest of 2026 and beyond, where is this going? Are we going to see more standardized tooling that makes this tax cheaper for smaller teams? Or is it always going to be the big iron of front-end development?
I think we are seeing a move toward integrated frameworks that handle some of this out of the box. Next.js and Remix are starting to incorporate patterns that feel a bit like micro front ends but with more safety. And the server components Shift in React is actually very related. It allows you to fetch data and render fragments on the server at a very granular level. I think the future is less about independently deployable repos and more about independently deployable components within a unified framework.
So, less separate apartments and more modular rooms that can be swapped out by a central management system. I can get behind that. It feels like a more balanced approach for companies that aren't quite at the Spotify scale, but still want to move fast.
The micro front-end tax is hopefully going to go down as the browser and the frameworks do more of the heavy lifting. But for now, if you are a small team, my advice is to stay in your monolith, keep it clean, and spend your complexity budget on features your users actually care about instead of infrastructure.
Spoken like a true donkey who has seen too many build pipelines break. I think that is a solid place to wrap up the technical deep dive. We have covered the what, the why, and the oh dear God why of micro front ends.
It is a fascinating space. It really represents the coming of age of front engineering, where we are finally dealing with the same massive scale problems that back-end engineers have been struggling with for decades.
We are all just trying to ship code without breaking things, man. Whether it is a tiny script or a distributed UI architecture, the goal is the same.
True, and hopefully this gave everyone a clearer picture of whether they should be paying that micro front-end tax or sticking with their reliable old monolith.
Before we go, if you enjoyed this dive into the architecture of the modern web, do us a favor and leave a review on whatever app you're using to listen. It actually helps other people find the show, which means we get to keep doing this.
Big thanks to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a huge thank you to Modal for providing the GPU credits that power the AI behind our scripts. They really make the whole My Weird Prompts ecosystem possible.
This has been My Weird Prompts. We're on Spotify if you want to follow us there and get notified as soon as new episodes drop.
We will be back next time with whatever weirdness Daniel throws our way. Keep your builds fast and your dependencies shared.
Or just don't have any dependencies. That's my sloth dream. See ya.
See ya.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird